equation contains a non-polynomial derivative term, then the degree of such a differential equation is not defined. Now the process of converting equation of x and y to differential equation using derivative, that is called as forming of differential equation. Okay, power of this highest order derivative in this case is 1. Note that the power of this is 4, but that doesn't count because that's not the highest order. Now let's start by understanding what do we mean by differential equations. Differential equations are the equations that contain derivative term in those. Okay, so any equation that contains a derivative term, it's a differential equation. Okay, let's look at that with the help of an example. So if I have d3y by dx cube minus dy by dx is equal to 10, this contains two derivative terms. I have d3y by dx cube and I have dy by dx. Since this equation contains derivative terms, this equation is a differential equation. Okay, this is a differential equation. Now let's look at that in more detail. Before looking at that equation in more detail, let us understand some notations. Okay, so whenever you have dy by dx, remember that in order to get dy by dx, you have to differentiate one time. Okay, in order to get dy by dx, you take derivative once, only then you get dy by dx, which is why the dy by dx term is called as first order derivative. Dy by dx is called as first order derivative, and the first order derivative in this chapter will also be represented as y dash. Okay, so the dy by dx term, which is the first order derivative, it will be represented as y dash. Now d2y by dx square, in order to get d2y by dx square, you will have to differentiate two times. Now since you will have to differentiate two times, this d2y by dx square is called as second order derivative, second order derivative, and it is represented in this chapter also as y double dash. And similarly, if it was d3y by dx cube, it will be the third order derivative represented by y triple dash. Okay, if it is the nth order derivative, dny by dx to the power n, you will have to differentiate n times in order to get this term. Hence, this is called as nth order derivative. This term is called as nth order derivative, and it is also represented in this chapter as y suffix n for nth order derivative. Okay, so in this equation example that we had, this d3y by dx cube is a third order derivative. This is a third order derivative, and this dy by dx is a first order derivative. Okay, so there were two derivative terms, which was one was third order and one was the first order derivative. Now it's time that we look at in detail what is order and degree of a differential equation. Okay, we just looked at order. In a differential equation, order of a differential equation is basically the highest order of the derivative present. Highest order of derivative present. We'll see with the help of an example to make it clear. Highest order of derivative present. Let's see with the help of an example. We'll use the same example that we had. So in this example, I have a third order derivative and I have a first order derivative. What is the highest order of derivative present here? Is third order. Hence, the order of this entire differential equation is 3, because order is the highest order of the derivative present in a differential equation. The highest order, so there are two derivative terms. One is the third order, one is the first order. Since the highest order is 3, order of this differential equation is 3. I hope that makes sense. So order of a differential equation is nothing but the highest order of the derivative present. Now next, the degree of the differential equation. Degree of a differential equation is power. So degree is nothing but power or exponent. Degree of a differential equation is power or exponent of that highest order derivative. This is very important. Of that highest order derivative. Let's look at the same example to understand. So degree of a differential equation is the order or exponent of that highest order derivative. So let's see here. So in this example, for this d3y by dx cube, the power or exponent of this is 1. Hence, the degree of differential equation is 1 because the power of that highest order is 1. Therefore, degree of this differential equation is 1. So degree is always the power or exponent of that highest order derivative present. If there was a square here, the degree would have been 2. If there was a cube here, the degree would have been 3, and so on. Okay, so I hope there is the distinction clear between what is order of a differential equation and what is the degree of a differential equation. Now, there is an important note that I would like to highlight, and I would like that you students remember regarding the degree of a differential equation. Now, there is a situation when the degree of a differential equation is not defined. Let's see what that situation is. Now, if a differential equation, let's say if I have a differential equation that contains a non-polynomial derivative term, okay, I'll give you that an example. So if a differential equation contain a non-polynomial derivative of a differential equation will contain a non-polynomial derivative term, then if a differential equation contains a non-polynomial derivative term, then the degree of such a differential equation is not defined. Note that it is still a differential equation. It is just that the degree of that differential equation is not defined. Let me give you an example to show you what do we mean by non-polynomial derivative term. To understand that, let's see what a polynomial derivative term is. So let's say if I have dy by dx to the power 10. Since this is dy by dx to the power 10, this is a polynomial derivative term. Okay, let's say if I have d3y by dx cube to the power 5. This is also a polynomial derivative term. Okay, let's take a couple of more examples. If I have d2y by dx square to the power 2, this is also a polynomial derivative term. So what is non-polynomial derivative? Now, if a derivative is, if a differential equation contains the derivative term like sine dy by dx, this is a non-polynomial derivative because it's sine of dy by dx. It's not a polynomial term, okay? It's sine dy by dx, which is a non-polynomial derivative term. Okay, let's say if it was log dy by dx or log d2y by dx square. Okay, this is also a non-polynomial derivative. If it was e to the power dy by dx, this is also a non-polynomial derivative. Okay, so if whenever a differential equation contains the term which are non-polynomial, so polynomial is basically just the power, right? So if dy by dx to the power 10, power 2, power 1, and so on, uh, in such cases the degree is defined. Okay, but whenever a differential equation contains non-polynomial derivative terms like sine, cos, tan, log, e to the power, and so on, if it is anything other than polynomial, the degree of such a differential equation is not defined. Now, let's take an example to make this concept even crystal clear. Okay, let's take an example of a differential equation. Let's say I have a differential equation d3y by dx cube minus log d2y by dx square is equal to 10, let's say. Okay, so since this equation contains derivative, this is for sure a differential equation. This is for sure a differential equation. Okay, let's see the order and the degree of this differential equation. Now, there are two derivative terms. One is d3y by dx cube, which is the third order derivative. d2y by dx square is the second order derivative. So the highest order of the derivative present is 3, which is why the order of this differential equation is 3. Now let's look at the degree. Degree is very important. Now, since this differential equation contains log d2y by dx square, which is the non-polynomial. Log d2y by dx square is a non-polynomial derivative term. Whenever a differential equation contains a non-polynomial derivative term, such a differential equation, the degree is not defined. Okay, I hope that makes sense. A differential equation with a polynomial which only contains the polynomial derivative term, you can define the degree. But if it's a non-polynomial, if it contains a non-polynomial derivative terms, in such cases, the differential equation's degree is not defined. I hope that makes sense. Now that we understand the basics of differential equation and what the order of the differential equation and the degree of the differential equation is, let's move on to the next concept, which is forming and solving of the differential equation. Let's see what that is. Now, in this chapter, you will deal with two types of problems. One is based on the forming of the differential equation, and another is solving of a differential equation. There are just two types of problems here, either on forming or solving. Let's see what forming is and what solving is. Let's say if you have an equation in x and y. Now, the moment you differentiate that equation, which is equation in x and y, when you differentiate that or take derivative, the equation that you get is a differential equation. So if you want to go from x equation in x and y to differential equation, you will have to take derivative. Okay. And if you have the equation, a differential equation, and if you want to get equation in x and y, if you want to convert the differential equation into the equation in x and y, you will have to integrate, which is the reverse of derivative. Okay. Now the process of converting equation of x and y to differential equation using derivative, that is called as forming of differential equation. Okay. When you go from equation in x and y, you take derivative and you get differential equation. That process is called as forming of a differential equation. And the reverse, which is if you have a differential equation, you integrate and you get equation in x and y, that process is called as solving of a differential equation. Okay, so there are just two types of problems here that we will deal. One is forming, which is you take derivative of equation in x and y to get a differential equation, and the other is solving, which is if you are given a differential equation, you integrate and you get the equation in x and y. Okay, which is called solving of a differential equation. I hope that difference is clear. Now that we understand the concepts of the order and the degree of the differential equation, let's try to solve some examples. In the first example, we have d4y by dx to the power 4 plus sine y triple dash is equal to 0. Since it contains the derivative terms, this is a differential equation. From the notations, we know that this y triple dash is nothing but d3y by dx cube. It's the third order of derivative of y with respect to x, since there are three dash. Okay, so this is the third order derivative of y with respect to x. Let's try to find the order of this differential equation first. Now, in this differential equation, there are two derivative terms. One is the fourth order derivative, the other is the third order derivative. Okay. Now, since the highest order of the derivative present in this differential equation is 4, hence the order of this differential equation is 4. In exam, you have to write it as, since the highest order of the derivative present in this differential equation or in this equation is 4, therefore the order of this differential equation is 4. Okay, now let's look at the degree. Now, if you observe that there is a sine d3y by dx cube term, whenever a differential equation contains a non-polynomial derivative term like we studied, the degree of such a differential equation is not defined. In this differential equation, this sine d3y by dx cube, this term is non-polynomial derivative. This is a non-polynomial derivative term. Whenever a differential equation contains a non-polynomial derivative term, the degree of such a differential equation is not defined. In exam, you have to write it as given differential equation contains a non-polynomial derivative term. Therefore, the degree of such a differential equation, degree of this differential equation is not defined. I hope that makes sense. Let's look at next example. It says y dash plus 5y is equal to 0. We know that this y dash is nothing but dy by dx, which is the first order derivative of y with respect to x. Let's try to find the order of this differential equation first. Now, since this dy by dx is the first order derivative of y with respect to x, and this doesn't contain any other derivatives, this just contains one derivative term, which is the first order derivative. Therefore, the highest order of the derivative present in this differential equation is 1. Therefore, order of the differential equation is 1. Okay, since it contains the highest order derivative, which is 1, okay, because it's the first order derivative. Now let's look at the degree. In order to find degree, you see the power of that highest order derivative. Now, if you see, the power of this highest order derivative is 1. Since the power of this highest order derivative, which is dy by dx, is 1, so we say power, since the power of the highest order derivative present in this differential equation is 1, therefore the degree of this differential equation is also 1. I hope that makes sense. All right, let's look at next example. There are two derivative terms, ds by dt to the power 4 and d2s by dt square. Okay, let's try to find the order first. Now, if you notice in this is the second order derivative of s with respect to t, and this is the first order derivative of s with respect to t. Okay, so this contains two derivative terms. One is the second order derivative, one is the first order derivative. Now, since the highest order derivative present in this equation is 2, because this is the second order derivative, this is the first order derivative. So the highest order of the derivative present is 2. Therefore, the order of the differential equation is 2. Okay. So order is always the highest order of the derivative present. In this example, the highest order of the derivative is second order derivative. So the order is 2. Now let's look at the degree. The power degree is nothing but the power of the highest order derivative. In this case, this is the highest order derivative, d2s by dt square. The power of this power of this highest order derivative in this case is 1. Note that the power of this is 4, but that doesn't count because that's not the highest order. The power of the highest order derivative, which is d2s by dt square, is 1. Therefore, we say the degree is 1. In exam, you have to write it as since the power of the highest order derivative is 1, therefore degree in this case is also 1. I hope that makes sense. All right, let's look at this next example. d2y by dx squared, the whole squared, plus cos dy by dx is equal to 0. Now let's try to find the order first again. In this, if you notice, there are two derivative terms, d2y by dx square, which is the second order derivative, this dy by dx, which is the first order derivative. Since the highest order in this differential equation of derivative is 2 of this second order derivative, this is a second order differential equation. In exam, you have to write it as since the highest order of derivative present in the equation is 2, therefore the order of this differential equation is 2. Let's look at the degree. Degree is very important again. If you notice, there is this cos dy by dx term. Whenever there is this non-polynomial derivative term, cos dy by dx, this is a non-polynomial derivative. Non-polynomial derivative. Whenever there is this non-polynomial derivative term, we know that degree of that differential equation is not defined. Therefore, in this case, since the differential equation contains a non-polynomial derivative term, the degree is not defined. Okay, I hope that makes sense. The next example says d2y by dx square is equal to cos 3x plus sine 3x. Now there is just one derivative term present, which is the second order derivative. So it is very clear that the order of this differential equation is 2 because of this second order derivative. Okay, so since the highest order of the derivative present in this equation is 2, therefore order of this differential equation is 2. Okay, now in order to find the degree, we have to see that what is the power or exponent of this highest order derivative. In this case, the power or exponent of this highest order derivative is 1 because it's d2y by dx squared to the power 1. Okay, so we can say since the power of that highest order derivative is 1 because that exponent of that highest order derivative is 1, the degree of this differential equation is, sorry, 1. I hope that makes sense. All right, let's look at this next example. It's a very interesting one. We have y triple dash square plus y double dash cube plus y dash to the power 4 plus y to the power 5 is equal to 0. Now, since from our previous discussion, we know that this y triple dash is nothing but the third order derivative of y with respect to x. So d3y by dx cube. This y double dash is d2y by dx square, which is the second order derivative of y with respect to x. And this y dash is nothing but dy by dx, which is the first order derivative of y with respect to x. Let's try to find the order first. Now, since the highest order of the derivative present in this differential equation is 3, the order of this differential equation is 3 because we have this highest order derivative, which is third order derivative, because there is this third order, second order, and first order. So the highest derivative order present is the third order derivative. So since the highest order of the derivative present in this equation is 3, therefore order of this differential equation is 3. Okay, I hope that's clear so far. Let's try to find the degree. Now, in order to find degree, we generally look at the power of that highest order derivative. Okay, so in this case, the third order derivative is the highest order derivative, and the power of that third order derivative is this 2, okay, which is the square. So we say since the power of that highest order derivative is 2, therefore, the degree of this differential equation is 2. Note that there are this d2y by dx square has power 3, this dy by dx has power 4, and there is also power 5. But none of those higher powers count because in degree, we only look at the power of the highest order derivative. That's the rule. Always look at the power of the highest order derivative. Okay, so since in this case the power of that highest order derivative is 2, therefore the degree of that differential equation is 2. Okay, I hope that makes sense and it's clear so far. Now let's look at a very similar example. We have y triple dash, which is the third order derivative, plus 2y double dash, which is the second order derivative, and y dash is equal to 0. Now in this case, this y triple dash is d3y by dx cube, the third order derivative of y with respect to x. This y double dash is the second order derivative of y with respect to x, and this y dash is the first order derivative of y with respect to x. Now, since there are three derivative terms and the highest order of the derivative present in this equation is 3 because I have third order derivative, that is the highest order, my order of this differential equation is 3. So I say since the highest order of the derivative present in this equation is 3, which is this third order derivative, my order is equal to 3. Now let's look at the degree. Degree is always the power or exponent of that highest order derivative. In this case, the power of that highest order derivative, which is d3y by dx cube, is 1. So we say power of the highest order derivative is 1. Therefore, the degree of this differential equation is also 1. I hope that makes sense so far. All right, this next example, we have y dash plus y is equal to e to the power x. We know this y dash is dy by dx. Okay, so this is the first order derivative, and this is the only derivative term present, which is the first order derivative. So since the highest order of the derivative present in this equation is 1 from this first order derivative, therefore order of this differential equation is 1. Okay, very simple. Also, let's find the degree. In order to find the degree, we look at the power or exponent of that highest order. We know that here the power or exponent of that dy by dx is 1. Okay, so since the power of that highest order derivative, which is dy by dx, is 1, therefore the degree of the differential equation is 1. Okay, I hope that makes sense. Let's look at the next example. We have y double dash plus y dash squared plus 2y is equal to 0. In this case, this y double dash is dy by dx. Oh, sorry, it's d2y by dx square, the second order derivative of y with respect to x. This y dash is dy by dx. Okay. So if we want to find the order, order is the highest order derivative. In this case, the highest order derivative is 2 because this is from the second order derivative. So since the highest order derivative present in this equation is 2, therefore order of this differential equation is 2. Now degree is nothing but the power or exponent of that highest order derivative. So the power of this highest order is 1 because there is no power. So there is power 1 on this highest order derivative. So since the power of that highest order derivative is 1, therefore, the degree of the differential equation is also 1. Note that there is power 2 here, but that doesn't count because this is not the highest order derivative. The highest order derivative is second order derivative. So we always look at the power of the highest order derivative. In this case, it is the second order derivative. So which is why the degree is 1. Okay, I hope that's clear. Let's move on to the next example. It says y double dash plus 2y dash plus sine y is equal to 0. Again, similarly, this is d2y by dx square. This y dash is dy by dx. So this is the second order derivative of y. This is the first order derivative, y dash, with respect to x. So there are two derivative terms. The highest order of the derivative present in this question is 2. So since the highest order of the derivative present in this equation is 2 from this second order derivative, therefore the order of this differential equation is 2. Okay. Again, we look at the power of that highest order derivative. Again, it is 1 because it's d2y by dx squared to the power 1. So since the power of that highest order derivative is 1, therefore the degree of this differential equation is 1. I hope it's very clear. It's a very simple concept of order and degree. Once you understand, it's very easy to solve those questions. All right, let's move on to the next example, which is the multiple choice question. The question says the degree of the differential equation is what? Now, if you notice in this term, there is this sine dy by dx term. Okay. Now, whenever you see a non-polynomial derivative term in a differential equation, the degree of such a differential equation is not defined. So note that this sine dy by dx is a non-polynomial, derivative. Okay. Note that the non-polynomial term should be in the derivative. So just like sine dy by dx, cos dy by dx, log dy by dx, e to the power dy by dx, and so on. Okay. Whenever the derivative is present in a non-polynomial function, such a differential equation's degree is not defined. So in this case, because of this non-polynomial derivative being present, the degree of this differential equation is not defined. I hope that is clear. All right, let's look at the next example. We have the order. Let's find the order of this differential equation. Again, a multiple choice. Uh, in this case, this is the second order derivative. This is the first order derivative. Okay. So if you want to find order, order is nothing but the highest order of the derivative present in a differential equation. So in this case, this is the second order, this is the first order. So the highest order of the derivative present in this differential equation is 2, which is why the order of the differential equation is 2. Note that in the previous example, the degree is not defined. Okay, we can define the order. The order was 2 because the highest order of this derivative present in this differential equation is 2. It is just that the degree of such a differential equation where there is non-polynomial derivative present is not defined. Okay, you can always define order. You cannot always define a degree. Okay, make sure you have clarity on that distinction. In this case, the order of the differential equation is 2 because of this second order derivative. Okay, I hope that makes sense.